Relative velocity. By definition, we've created a situation where displacements are always measured relative to some arbitrary position. Well, you can have situations where objects are moving relative to objects moving relative to other objects. For example, you can have a treadmill that's moving this way relative to a floor, which to our perception might be a stationary reference. And you could walk across the treadmill relative to the treadmill to the right. If you were to do that, what would happen is relative to the floor, you would travel up and to the right. And the reason for that is that whenever you're dealing with multiple reference frames that are moving relative to each other, you can figure out what the velocity would be relative to one reference in the following way. The velocity of u relative to the floor would be equal to the velocity of u relative to the treadmill plus the velocity of the treadmill relative to the floor. And there's something, if you line these things up this way, it always works. What you do is you take the intermediate reference, which is the treadmill, and you kind of make a sandwich, meaning what you want to know is u relative to floor. So what you do is you take the first reference, u, and line it up with your intermediate reference. So you know u relative to the treadmill. And then you make the other one, then the velocity of the treadmill, the common internal reference, versus the second reference. And anytime you set up this kind of sandwich like this, you will always appropriately calculate the velocity of the first relative to the velocity of the last. So let's give these things some numbers. Let's say this was let's say this was 4 meters per second, and this was 3 meters per second. Well, how do we do this? Velocity of u versus the treadmill, that's 3 meters per second to the right. And we want to add to that the velocity of the treadmill relative to the floor. Well, that's 4 meters per second up. And the vector sum, according to our equation, is what we want, which is the velocity of us, u, versus the floor. And in that case, your velocity, in this case, will be part of a right triangle just based on the directions of the vectors, which means that our velocity will be equal to the velocity of pen is just not cooperating. There we go. Velocity of u versus the treadmill squared plus velocity of the treadmill versus the floor squared. And in that case, that would be 3 squared plus 4 squared. The square root of that would be 5 meters per second. So this is more or less the trick to the whole thing. Anytime you have relative velocity of multiple things moving relative to multiple things, you can work out whichever thing you want moving relative to whichever thing by making this kind of reference sandwich, where the first of the first term should be the first subscript in what you want. The second of the second term should be the second subscript of what you want. And they must then link up to a common reference that you know both of them relative to, that then go in the middle.